Hello everyone. So last time we solved sums on permutations where there were no repetitions. Okay. So this time we'll solve sums involving permutation where there is repetition. So let us start. So suppose if you have something like this. If you have n total number of objects, okay. Suppose if there are n total number of objects. Objects, as I said last time, can be anything. Can be alphabets, digits, can be a number of people. Okay. So whenever you have a number of colors, balls of the same colors or anything like that. So whenever you have objects or total number of objects as n, and where not all objects are distinct. Not all are distinct. Distinct means different. Okay. Where not all are different means there are something. There is some kind of similarity between the objects. Okay, there is some kind of similarity between the objects where out of these n में ही n से ही if suppose n1 objects, n1 मतलब some specific number of objects are of one type, and where n2 objects are of second type. Okay, so in total we have n number of objects और उसके अंदर suppose we have n1 number of objects of one type and n2 number of objects are second type. मतलब n1 के objects है वो सब एक एक हैं और n2 जैसे objects है वो सब एक हैं. So then इसके the number of permutations are given as n factorial upon n1 factorial into n2 factorial. Okay, so this is just in general if I'm talking about just two objects, मतलब objects of just two type. तो ऐसा तो तुम्हारे पास कितने भी हो सकते हैं. सपोज n ऑब्जेक्ट्स है और उसमें n1 ऑब्जेक्ट्स ऑफ n1 टाइप, n2 ऑब्जेक्ट्स ऑफ सेकंड टाइप, n3 ऑब्जेक्ट्स ऑफ थर्ड टाइप, n4 ऑब्जेक्ट्स ऑफ फोर्थ टाइप. ऐसे तो यू कैन हैव सो मेनी ऑब्जेक्ट्स ऑफ सो मेनी टाइप्स, राइट. So in general if we have n objects and उसमें if we have n1 of type 1 objects, n2 number of type 2 objects, so on and so forth till n k number of type k objects, then this is given as n factorial upon, ये सिर्फ for extend होता है. How many number of objects you have, that many times you have to extend this. This will go till nk factorial. Okay, so this is just a formula you have to remember. Now we'll solve sums based on this. So if suppose this is a solved example, this is a word given to you, COMMON. So this we know, this is of the repetition type because we can clearly see that M repeat हो रहा है, O repeat हो रहा है. The alphabets are not all distinct, right? They're not all different. So find the number of distinct words that can be formed from the letters of this word common. Okay, so you have to find out the total number of distinct words that can be formed from this letters of this word common. Okay, so how will this be done? As I said, n is the total number of objects, right? N factorial upon n1 factorial into n2 factorial. This is the formula that you're going to use. Okay, so यहाँ पे in total how many objects do we have? Objects means, as I said, that can be number of letters, alphabets. Here we have the number of objects as letters. 1, 2, 3, 4, 5, 6, right? 1, 2, 3, 4, 5, 6. So we have 6. So n is equal to 6. And in may say this, what did I tell you? What is that? N1 and N2 are those objects which are of one type, right? So यहाँ पे O is something that is repeating twice. M is that alphabet which is repeating twice. मतलब M is of one type, O is of one type, right? C and N, they're not repeating, so we are not concerned about that. So यहाँ पे we can write the letter common, the word common has 6 letters, and out of these O and M are repeated twice. Yes. So that is why now the total required number is nothing but n factorial upon n1 factorial into n factorial n2 factorial tha. So this will be 2 factorial into 2 factorial. Okay. So this is something you will have to solve. So this is Nothing but 720 divided by 2 into 2, that is 4. So the answer will be 180. Okay, so this is one question where the question is based on repetition of objects. Okay, suppose we have another question where a coin is tossed 8 times. Okay, a coin is tossed 8 times. The total times we have is 8. इनमें से in how many ways we can obtain 5 heads and 3 tails, right? So means 5 times heads are repeating and 3 times tails. So the second sub question is at least 6 heads. The third is at most 3 tails. Okay. So a coin is tossed 8 times. In how many ways we can obtain the following things? 5 heads and 3 tails. Okay, so the first one is much easy and it is similar to the above this thing. So इसमें क्या आएगा? The total number of times, so that is 8 factorial upon 5 heads, right? So 5 times a head, so that is repeating 5 times, and tail. So whenever you toss a coin, you just have problems of two types. You'll either get a head or you'll either get a tail. There is no other third type, correct? So यहाँ पे 5 heads के लिए and this is for 3 heads. Okay, so this is something you will have to solve and write the answer. Now the next one, the next sub question is at least 6 heads, right? At least 6 heads मतलब क्या? At least means minimum, right? कम से कम. More than 6 will of course do, right? So 6 heads, will it do? Yes, of course 6 heads will do. 7 heads, will it do? Yes, of course 7 heads will also do, because they're telling you at least 6 means 5 will not do, 4 will not do, 6 and more than 6 will do. 6 heads will do, 7 heads will do, 8 heads will also do. Will 9 heads do? No, 9 heads will not do, because the coin is only tossed 8 times. So 9 is like beyond the number of times the coin is being tossed, right? So 9 is not possible. So you can either have 6 number of heads, 7 या फिर 8, राइट? अगर अभी 6 नंबर ऑफ हेड्स है तो रिमेनिंग नंबर कितना होगा? टेल्स का, राइट? सो रिमेनिंग नंबर मीन 6 हेड, सो द रिमेनिंग 2 विल बी tails, because in total 8 है ना, the number of times the coins are tossed. So 6 times we're getting heads, so 2 times you will have to get a tail. The coin cannot stop somewhere in between, right? So it is either heads or tail. So when there are 7 times heads means there is only one tail, right? When there are 8 heads, then there is nothing in terms of tail. So there is nothing means 0. All right. So now coming to writing this problem, at least 6 heads. So this is again we will do the same thing. At least means ये वाला condition होगा या तो ये वाला या तो ये वाला. It is not like all the three. They said at least means या तो 6 heads है या तो 7 heads है या तो 8 heads है. So this is like either this or this or this. And in the addition principle, when we started this lesson in the beginning, while we were doing fundamental principle of counting, I did tell you all that or means addition and means multiplication, correct? So you have to keep that thing in mind. And now we are using or, correct? And using that repetition wala concept, which we just did few minutes back. The total is 8 factorial upon the first case. The first case where 6 heads repeats and 2 tails repeats. So that is 6 factorial, 2 factorial, right? और है ये वाला एक कंडीशन या तो ये वाला कंडीशन. तो ये वाला कंडीशन जो फर्स्ट हमने लिखा है वैसे ही we will write the second condition, but since because of the word or, that is nothing but the addition principle, the second case is 8 factorial or this one. So for this we have 7 factorial into 1 factorial plus the last one is 8 factorial upon 8 factorial into 0 factorial, and I've already told you that 0 factorial is equal to nothing but 0. Sorry, that's equal to 1. 0 factorial is equal to 1. So that also we have discussed last time. Okay, last time or last to last time, I don't remember. So these things you will have to solve and write the answer. So whatever answer you get, this one plus this answer plus this answer. Okay, so I will just quickly write down. So this is nothing but 28. This will be 1 factorial will be 1. यहाँ पे 8 factorial है तो 8 factorial you will write it as 8 into 7 factorial. Don't write 8 into 7 into 6 into 5 because you already have 7 factorial in the denominator, so we know that somewhere it is going to get cancelled. So 8 factorial को I'll write it as 8 into 7 factorial and then 7 factorial and 7 factorial getting cancelled. So we just have 8 over here. ये तो दोनों similar है, so that will also get cancelled. So on adding, we get the answer as 37. Okay, that was the second sub question. Now the third one. Okay, so third one says at most 3 tails. Okay, at most 3 tails means what? ज्यादा से ज्यादा सिर्फ 3 ही tails हो सकता है. 4 tails बिल्कुल भी नहीं चलेगा. Okay, so they can have at the most 3 tails means either they can have zero number of tails, either they can have one tails can repeat zero number of times, one number of time, 2 times, 3 times. That's it. It cannot go beyond three. So three means at most means max to max, not beyond that. Four times the tails are getting. So that is something that is not okay. So then when you have zero tails, this is what we are going to do it in the similar way जैसे हमने पहले के question में किया था. This is like at least 6 heads. So they were actually talking about heads. तो मैंने heads का numbers पहले fill कर लिया and then accordingly we did for tails and then we wrote it properly. यहाँ पे at most 3 tails बोला है, so I am going to do it for tails first and then we will do it for heads. So zero tail means all are heads. That is one condition. Or else, I'm not writing factorial over here. We'll write that a little later. Okay. So when the one time tail is repeated, means the remaining 7 times they were heads. 2 times tail means remaining 6 times head, right? 3 times means the remaining 5 times as head. So again, यहाँ पे भी same condition. This one or this condition or this condition or this condition. So or again means addition because of the addition principle. And the first one. So we will write it like how we wrote it in the previous sum. 8 factorial is a total, that is n factorial upon n1 factorial into n2 factorial. So that is nothing but 0 factorial into 8 factorial plus 8 factorial upon now this one. 1 factorial into 7 factorial plus 8 factorial upon 2 factorial into 6 factorial plus 8 factorial upon 3 factorial into 5 factorial. Okay, so all these sums you will have to calculate the answer. इसमें से see this answer तो we already have these two answers we already, this is nothing but 1, this answer is 1 and ये वाला 8 factorial upon 7 factorial and 8 upon 2 into 6. So all these answers we have already, right? यहाँ से. So we just have to calculate this answer. Okay, all the remaining answers हमको ऊपर वाले इसमें से मिल गया. Then what remains is that was already equal to 37, the first 3 terms, right? 1, 2, 3. This was already there in the above question. This answer is 37. So I'll write that as it is. Plus remaining इसी का answer तुमको find करना है. This will be nothing but 8 into 7 into 6 into 5 factorial because I know that 5 factorial is there in the denominator. It will get cancelled. So I'll cancel these two. 3 factorial is nothing but 3 into 2 into 1. That is same as 6. So I'm cancelling this as well. So 37 plus 8 sevens are 56. So answer is 93. Okay, that was one example. So you have many such examples in the exercise 6.4. They're giving you many words. Okay, जिसका आप ऐसे ऐसे ही करना जैसे we did it for the word common. You have to do it likewise. Like they're giving you example related to color of balls, color of marbles, the types of books. Okay, so those things also you have to do it in a similar way. Now, in case if just that they make a change, abhi, जैसे we did it for alphabets, we did it for a problem related to tossing a coin. Suppose if they give you a big number, okay, the digits are number. How many distinct 8-digit numbers can be formed from digit 62270 This is again based on repetition. You can clearly see, and there are 1, 2, 3, 4, 5, 6, 7, 8, 8 digits, right? So n factorial upon जैसे हमने वहां पे किया था what all things are repeated उसका number of factorial. So right, 2 is of one type, 1, 2 and 3. So 2 is repeating thrice, so 3 factorial, and 0 is repeated how many times? Only 2 times. So this is the final answer. So on doing this, you will get the final answer as 3360. Okay, so this is one. So you can have any such problem related to alphabets or any objects of that type. Okay. So Now we can come to circular permutations. That's the next topic. Circular permutations. Just a second. Now, suppose circular permutation, as the name says, whenever you have to kind of arrange objects, not in a straight line. जैसा अभी तक कि हमने हमेशा बोला था कि the digits are arranged like this or the words are arranged like this in a straight line. But circular permutation, as the name says, whenever you have to arrange objects in a circular form, जैसे round table conference हो गया, so that is like nothing but a round table or dining table में in a circular dining table if the people are to be arranged. So all the examples that are related to when people are to be arranged in a circular form. Okay. For example, if there are three people, okay, Ramesh, Suresh, and Dinesh, okay, they have to be seated in a round table for a dinner. So how many different ways they can be seated? That is what is an example of circular permutation. So I'll explain to you that. Um, so we will see how they are to be seated. Suppose agar circular hai, we have three places, three people, right? Ramesh, Suresh, and Dinesh. So it's our choice, right? Suppose they can be seated like this: Ramesh here, Suresh here, Dinesh here. That is also possible. Nahi to, that's not the only possibility, right? Nahi to Ramesh over here, Suresh over here, Dinesh over here. That is also okay. Or else Suresh over here, Dinesh over here, and Ramesh over here, right? So it is like all your choice, right? So यहाँ पे these are the different types of permit. Yes. So now from this example, you may feel that ये दोनों ये वाला जो part है इसमें से suppose just for an example, I am considering with Ramesh's position. Okay, we have Ramesh, then Dinesh, and then Suresh. So it is going like this, correct? और यहाँ पे भी the second one से Ramesh, Dinesh, and then Suresh. So this is also going like this. मतलब ये ऐसे ही जा रहा है clock के reverse position में. Clock हमेशा ऐसा घूमता है, right? This way. 1 2 3 4 like this. But ये वाला जो circular motions है, the first two examples, they are going like this, right? So they are actually opposite in the direction of the movement of clock. So these are called as anti-clockwise movements. Okay. But on the other side, if you see this thing, Ramesh and then यहाँ पे जो था, see these two examples you had, first Ramesh and then Dinesh, right? We are going in that order. यहाँ पे भी Ramesh and then Dinesh in the ulta side, anti-clockwise side. But यहाँ पे if you see, first we have Ramesh and then Dinesh and then you have Suresh. Okay, so we were doing circular permutations. So I would like to give you an example. So that example that I had given was in case if there are three people, Ramesh, Suresh, and Dinesh. Okay, so they are to be seated for a dinner in a round table. So we have to see how many different ways this can be done. Okay, so suppose this is a round table, all right, and randomly we're just giving them position. Suppose Ramesh is sitting over here, Dinesh is sitting over here, and then Suresh is sitting over here. Or else, then other ways, suppose Ramesh is sitting over here, Dinesh is sitting over here, and then Suresh is sitting over here. Or else the other ways, suppose Ramesh is sitting over here, Dinesh is sitting over here, and then Suresh is sitting over here. So we can, if you just carefully notice these three figures, regarding the arrangement of the people. Before that, I would like to tell you all one thing. If we consider this example with respect to, okay, we start with the movement, start counting, start seeing their position with respect to Ramesh's position. This is just an example. Ramesh we have, and then we have Dinesh, and then we have Suresh, right? So ये direction ऐसा घूम रहा है, रमेश से लेके दिनेश से लेके सुरेश से लेके, okay? और अगर if we consider in the second circle, Ramesh and then Dinesh and then Suresh we have. So this is again like this only. So मतलब both the places it is going like this, और यहाँ पे भी वो ऐसे आ रहा है, okay? So this is like this direction. How are they moving? This direction they are moving. And this one is again moving in this direction. Okay. Or the third example that you consider. Now the third example again we have Ramesh and then Dinesh and then Suresh. So these are also moving in this direction. So all the three circles are kind of moving in this direction. Are you understanding? This is the way how they rotate. So when you have this kind of rotation, the circular rotation, This is actually opposite to the movement of the clock movement, right? Clock हमेशा moves like this. Clock में you have 1 2 3, हमेशा clock ऐसे move करता है, it never moves उल्टा. So when these types of movements are there, which is actually opposite to the movement of the clock, you call it anti-clockwise movement. Okay, whereas the movement that is with respect to the movement of the clock, that is called as clockwise movement. ऐसा ऐसा गया तो that is called as clockwise movement. ऐसे ऐसे उल्टा हो गया, so that is called as anti-clockwise movement. Now when you see, consider these three positions of the people, the this thing, the type of arrangement may look different, but the order that these people are sitting in are actually the same. Ramesh, then uska anti-clockwise side say, if you see, the very next person is Dinesh, uska and very next person is Suresh. So the place is these people are sitting are absolutely the same, right? So you cannot have so many ways. ये जो तीनों ways है ना, ये actually तीनों अलग अलग ways नहीं है, ये same ही ways है. It's just that the three people are sitting in three different chairs. That is the only difference. बट अदरवाइज अगर मैं ये वाला सर्कल को ऐसे घुमा के देखूँ ना, ये वाला सर्कल को, तो एक पॉइंट पे मुझे यही सर्कल दिखेगा. ये सर्कल को if I just try to rotate and see, I'll get the third circle only. So all these three circles are not different ones, they are all three same positions only. So in total, as I said, you can only have these two types of opposite movements possible. All right. These two types of opposite movements means one is that anti-clockwise movement and the other is the clockwise movement. Suppose those two movements are nothing but this one. Suppose we have Ramesh over here, then we have Dinesh over here, and then we have Suresh over here. That is Ramesh, then uska this side, okay, like this. Dinesh and then Suresh, and the other way is nothing but Ramesh and then Dinesh and then Suresh. Now where is that this one sitting? Ramesh and then, are you understanding? So this is going in that opposite direction. Ramesh and then Dinesh and then Suresh. So in total, when we had three people, Ramesh, Suresh, and Dinesh, we only had two types of arrangements possible, right? So in total, whenever you will have n objects, in only in case of permutation combination, circular permutations, these are the total number of ways the people can be arranged or the objects can be arranged whenever we talk with respect to circular permutations. Okay, so whenever you have n objects, circular permutations are possible in n minus n factorial ways. Okay, suppose you have six objects and they are to be arranged in that circular table, alright, for a dinner or whatever it is. So then total possible ways will be 6 minus 1 factorial or 5 factorial. Likewise, if you have 10 objects, they are to be placed around a circular table, that will be possible in 10 minus way. That is same as 9 factorial ways. Okay. Now, in case if we have a question like this is similar to circular permutations. Okay, in how many ways um, can 8 students? Okay, so we have total number of students as 8. 8 students be seated in a round table so that two students or so that two particular students. So this is somewhat similar to that example we had done last time, where example just say of books have two particular books are always together. Likewise, so two particular students are together if students are seated with respect to each other. If students are seated with respect to each other. Okay, so how are we going to do is, last time also as I said, when you had those students when they are sitting together, how did we do that? We always had we had to consider them as जो जो बाजू में बैठा है उनका permutations हम लोग लेते थे, and the remaining permutations we used to take, and then we used to kind of multiply both the total number of cases, and then we used to get the total number of ways possible. So यहाँ पे you have to think about these two things. First of all, they are seated in a round table, so this is an example of circular permutation. And the other condition given is two particular, so that uh, two particular students, okay? Two particular students are always together. So how are we going to do this? Okay, yes. So how do we do this? So there are two particular students, right? So whenever we have those two particular girls, likewise last time also we had those three brothers were to be sitting together, so we consider them as one object only, right? So यहाँ पे भी those two students will be considered as one student or one object. If you're not understanding this one, please refer to the previous last week's video. वहाँ पे we had done sums where the objects were kept together. Okay. There was an example that I had taken where for a photograph or something, the brothers and sisters वाले sum में where the brothers were sitting together. So then we had to consider those brothers, the objects which are to be placed together as one object. So यहाँ पे we have two students to be always together. Yes. So now we have total number of objects as total number of students as 7. Yes, because initially we had a total of 8 number of students, right? For 8 में से there are 2 students, कोई 2 particular students ऐसा है, they will always sit together. तो वो 2 को हमने एक ही consider किया है, तो मतलब actually एक कम हो गया है, right? So now the total number of students we have as 7. Yes. So whenever you have 7 students, and now we have to make these 7 students sit in a circular table. As I said, when you have 10 students, they will be made to sit in 10 minus 1 factorial according to the formula that I just gave you here. So we have total abhi 7 students, right? So they will be made to sit in 6 factorial ways. Yes, according to the formula. That is nothing but 7 minus 1 into 7 minus 1 factorial, that is same as 6 factorial into now ये हमको 7 जो है ये कैसे मिला था after considering those two as one, but in reality that one student is not just one student, there are two students, right? So those two students will be internally made to sit amongst themselves in two factorial ways. Okay, so these problems also we had done last time. जैसे condition था on brothers, right? So we always consider those three brothers as one object. The remaining ones we did. फिर उनको बिठाने के बाद those three brothers were internally made to sit amongst themselves in three factorial ways. So this is same as that only. So you have to do it in that way. So then the total this thing becomes 120 into 4. That is 1440 total number of ways. Okay. So the next example that we're taking is find the number of distinct ways of seating 6 men and 6 women around a table. So whenever ऐसा words आता है around a table or around a circular table for a round table conference, something like that, वो तुमको strike होना चाहिए कि that is something to do with circular permutations. Okay, then there is no restriction. Okay, there is no restriction on what, on actually the gender, because they're talking about two types of people, right? 6 men and 6 women. So when there is no restriction, and the second one is no two women are seated next to each other. Are seated next to each other. Okay, so coming to the first criteria now. So there is no restriction on gender. So we're not really going to consider that how many number of men are there and how many number of women are there. So in total we have 6 men plus 12 plus 6 women. So we have total 12 number of people, right? So 12 persons are there. 12% है, the total number of possible arrangement to make them sit in a circular table will be how much? Total arrangements will be 12 minus 1 factorial, that is nothing but 11 factorial. Okay, and the second criterion is what? No two women are seated next to each other. Okay, so no two women are seated next to each other. This is similar again to the previous week sum of brothers and sisters, but the second criterion was no two brothers were sitting together. So there is a problem with the number of women to be seated, right? So women cannot be made to sit next to each other. So what we will do is, this is the one that is creating problem. So we will talk about the other object. So the other object is nothing but men, right? So in total we have 6 men. So right now we're not talking about women because these women are not meant to be seated together. Like last time का example देखा, अभी suppose 6 seats है, 12 seats है, right? 1 2 3 4 5, how many are there? 1 2 3 4 5 6 7 8 9 10 11 and 12. So these are the 12 seats, right? So they have to sit in a proper circular form. Abhi yahan pe you never want that if a woman is sitting here, then the other woman should not sit over here, right? So the other women can only sit over here. If a woman is sitting over here, then the other women cannot sit in this place. The women, the next one has to sit over here only. So ये जो remaining मैंने ये cross किया है, these are nothing but the positions that are actually for men. Okay, so that are actually for men. So we will first try to place the men because there is no restriction on the arrangement of men that is given to us in the question. So we will first try to place the men. So how many total number of men do we have in this question? 6 men, right? And the 6 men are to be arranged in a circular table. So this can be done in 5 factorial ways, right? That is nothing but 6 minus 1 factorial, which is equal to 5 factorial ways. Okay, so the end result answer is 120, but we'll come to that. So after making these क्या बोलते हैं, these men sit together, इसके बाद how many, what is the actual criterion, since no two women should actually sit together. Okay, so then we have no other choice than a woman sitting in between two men, right? हमारे पास 6 men है और 6 women है और total सिर्फ हमारे पास 12 ही seats है. So this is the only possibility we can have. If one woman is sitting over here, the other women will sit over here. Other women will sit over here. Other women will sit over here. These are blank places here. These crosses. I'm not writing it as M and W because M को invert करने के बाद it is looking like W only. So I'm just putting a cross. That cross means position of men. Okay. So these are all nothing but the positions of men. So how many remaining places are available for women now? We have 6 spaces, right? So there are 6 spaces between men and there are 6 women. So यहाँ पे 6 places में 6 women have, we have to fit them, right? So that can be done in 6 factorial ways. Okay. So now there are 6 spaces between. Now the men are already seated. So this can be done in 6 factorial ways. So the total number of ways are nothing but this one into this one. And this is because this number of ways and this number of ways. So that is we have a multiplication in between. Why did I use and? Is because you also have to make the men sit and you also have to make the women sit. Beach wale places cannot be khali, right? So this one and this one, you have to do both the functions. There's like a multiplication principle. That is why it is a multiplication sign in between. Unless if they tell you there is something called as at least, yeah, at most in the other examples that we saw, yeah, something to do with or. Okay, when you have options, so that time there will be addition. Okay, so after this you have few sums based on the circular permutation in exercise 6.5. After this we have to do combinations. Combinations are nothing but whenever I have already told you all the meaning of combination in the first class, while I was trying to distinguish between permutations and combination. Permutations is nothing but the rearrangement of objects and how many total ways it can be done. Combination is nothing but in how many ways can you select objects. So it basically deals with selection of objects or how many ways you can choose those objects. Okay, so total number of objects कितना है, उनमें से कितना object select करना है, likewise. Okay, so this basically deals with without repetitions. Okay, it is without repetition. Okay, suppose अगर 10 students are in a class and from there you have to select only 2 students, so that you can do in 10C2 ways. Okay, 10C2 is nothing but total number of students as 10, you have to select or choose, right, 2 students for a CR or whatever it is, so that is why it is a C, and then 2 students we have to select, so that we will write in 10C2 ways. Suppose we have 7 books and unme se we have to select 3 books, right? So that can be done in 7C3 ways. Suppose 4 total objects are there. Unme se I have to select only one object. So that will be done in 4C one ways. Now we will see how to solve these. Or formulas क्या है? So in general, when we have n number of objects, उनमें से suppose r objects are to be selected, that can be done in NCR ways, and the formula is n factorial upon r factorial into n minus r factorial. Okay, this is the formula. Suppose, for example, if we are calculating the value of 10C2, we can clearly see from the question n ka value is 10, r ka value is equal to 2. So we will accordingly substitute. N ka value is 10, r ka value is 2. So this is factorial, which is nothing but 10 factorial upon 2 factorial into 10 minus 2 factorial is nothing but 8 factorial. This is same as 10 into 9 into 8 factorial, because I know that 8 factorial is in the denominator, so we can easily cancel this one gone. So we have upon 2 factorial. 2 factorial is same as 2 into 1, which is actually equal to 2. So here we have 2 ones are 2 fives are 9 fives are 45. So the answer is of 10C2 is 45. So you have to use this formula. NPR का formula was n factorial upon n minus r, right? N minus r factorial. तो यहाँ पे C के लिए you have this extra addition r factorial का. Okay. Then there are few this thing you have to remember, few properties of combinations you have to remember. Suppose if you have this thing, something like the value of r as 0. Okay, if r is 0, that is nothing but ncr की जगह पे if we write it as nc0, ऐसा कुछ भी आए, then you don't have to solve it, the final answer is equal to 1 only. Okay, you don't have to solve for that. The solution is already given as a property, n factorial upon r factorial into n minus r factorial. This is the question, right? तो यहाँ पे हम r is equal to 0 सब्स्टिट्यूट करेंगे, और ये 1 कैसे आ रहा है, दैट आई एम टेलिंग यू, upon 0 factorial into n minus 0 factorial. So this is same as n factorial upon 0 factorial is 1, which we have done already. This is same as n factorial. So n factorial, so we just have 1. This is the proof of that property. You have few other proofs also. We'll do it as soon as we come to those. But few of the properties I would try to list right now, because we may use it coming sums. Suppose if we have NCR is equal to NCS, okay, then either this is like comparing, right? And then so R either will be equal to S, okay, either R will be equal to S, or else S will be equal to N minus R. Okay, so N is the total number of objects, और यहाँ से हम R number of objects को select कर रहे हैं, और यहाँ पे N है, उसमें से हम S number of objects को select कर रहे हैं. So if these two ways are equal, means the object selected in both the cases, that is R will be equal to S. If not, if either R is equal to X, or either or means या तो ये, okay. So either R will be equal to S, or if R is not equal to S, then S will be equal to N minus R, okay. The remaining number of objects, the total minus R number of objects that are already being selected, okay. And as I said, that there was this problem, this property we have already, actually it's not a very big property, we already know this formulas. ये वाला formula है, और this formula also we just did, n factorial upon r factorial into n minus r factorial. So we can clearly see that this part, this shaded part, n factorial upon n minus r factorial, this full thing is nothing but actually NPR, right? The shaded part, n factorial upon n minus r factorial is nothing but actually the shaded part. So we can rewrite this thing as NCR as NPR upon r factorial. Yes, so that is just one property. And the other property is suppose if you have something like this, NCR plus NCR minus 1, okay, NCR plus NCR minus 1. This means what? This first place out of n objects is selecting r objects, right? और यहाँ पे सेकंड दिस इज और n फैक्ट n ऑब्जेक्ट्स में से यू आर सिलेक्टिंग r से एक कम number of objects. So total number of ways this will be done will be n plus 1 into n plus 1 CR fact. Okay, n plus 1 CR. Just a second. All right. So this will be done in n plus 1 CR. Agar, for example, you can just take an example and you can check. Okay. Suppose if you have 5C3. Okay. 5C3 plus 5C2. This is same as the above this thing. 5 n की जगह पे हमने 5 लिया है r की जगह पे if we take 3 r minus 1 I've taken it as 2 this का आंसर और n plus 1 that is 6 c3 दोनों का आंसर will be same इसका फाइंड करके you add up the answers and that will be equal to 6c3 का answers okay just one last formula we would just like to tell you. The other property, suppose if you have NC0 plus NC1, so on and so forth, plus NC2 plus NC3, so on and so forth, till NCN. Okay. The entire addition ka answer will be 2 raised to n, 2 raised to total number of objects. Okay. This is what NC0 is means out of n objects, you're not selecting any objects. That is also like a choice only. Plus NC1 out of n objects you're selecting one object plus out of n objects you're selecting two objects plus out of n you're selecting three objects last में out of n you're selecting all n objects so what total number of ways will be equal to 2 raised to n that depend n is nothing but the number of total objects available okay we will try to solve a few sums based on this I think then combination is actually the last part of this lesson now suppose suppose if we have a question like this, find n and r. Okay, you have to find the values of n and r if some this thing condition is given to you. Okay, what is that condition? Suppose if I take up one sum from no, we'll take another example. Suppose you find out n. Okay, find n if NC8 is equal to NC6. Okay, NC8 is equal to NC6. And you can see that ये जो है, this is somewhat similar to a property that we had done. If NCR is equal to, just a second.